Hi guys, happy Monday. This is the video on what makes up an atom. And so today we're going to talk about the parts of the atom. Make sure you understand all the vocabulary. You're ready to go for tomorrow's quiz. The first thing we're going to talk about is the two major sections of the atom. Everybody should remember the center part of the atom is called the nucleus. We should remember that that is in the center of the atom. It is positively charged because of those protons in there. It gives that nucleus a positive charge, and it is 99% of the mass of the atom. It's only 1% of the space, but 99% of the mass. So it's very, very dense. Lots and lots of matter in a very small spot there. The second thing we talked about was the electron cloud. So this is the other part of the atom if you want to break the atom into two sections. So you have the nucleus, the very dense center, and then you have the electron cloud, the very large and expanding kind of area of the atom. This is where the electrons can be found. That's why we call it the electron cloud. It is negatively charged because of the electrons there. So you have a positive nucleus and then a negative charged electron cloud. And we also find in the electron cloud orbitals, and these are areas where electrons are likely to be found. That was based on our Bohr models. We imagine them like planets going around the sun, and they have orbits where we expect to find those electrons. Again, the electron cloud takes up about 99% of the space of the atom, and so it's very low density, very large compared to the nucleus, and negatively charged because of the electrons. We mentioned the protons and the electrons here, so let's make sure that we understand what those are. Protons, of course, are positive. They have a positive charge. The importance of the protons, what they really do for an atom, is they determine what element it is. So if you have an element with one proton, you have hydrogen. If you have an element with two protons, it is helium. You can change the neutrons, you can change the electrons. It will not change the element. If you change the protons, you will change the element. You'll turn it into something, a new element. They are, of course, found in the nucleus. The electrons are much smaller than the protons. They are negatively charged. What they really determine is the chemical reactivity, whether or not it's going to make chemical bonds with other elements. And so when we were talking about the Bohr models, those elements that seem to be have their shells complete and don't want to get any more electrons or lose any electrons, they are unreactive because they have all the electrons that they want. So electrons really determine how elements will make bonds with each other, chemical bonds. They are found in the electron cloud or on the electron shells if we're talking about the Bohr models. And the interesting thing about these is they're about 1/2000th the size of a proton. Because of that, we really don't count them when we're talking about the atomic mass or the atomic weight or the mass number. We really can ignore the electrons because they are so small. The last particle that we find in atoms is the neutron. They are neutrally charged or have no charge. They determine really the stability or the nuclear stability of an atom. Remember, those protons are packed really tight in the nucleus, and protons want to repel other protons, so they need some way of staying near each other. And they have that strong force that holds them in there, but neutrons also give them a little bit of a buffering zone, so they're not touching each other. And so those neutrons really help keep those atoms stable. If you change the number of neutrons, you will change the isotope, and so you'll make different elements that have different mass numbers, but they are the same element. So changing the neutrons changes the isotope. The examples we talked about were carbon 12 or carbon 13 or carbon 14. They are all carbon, they all have 6 protons, but they do have different numbers of neutrons, giving them different stability. We also talked about the atomic number, making sure that we knew where that was on the periodic table and how to find it. When you're looking at the periodic table, it is the number above the symbol. It, of course, tells you the number of protons in the element. It is found on the top of the element box. Right there you can see it, the 2 above the helium. and that number is not going to ever change. That is just the number of the element. Because it has 2 protons, if you change those protons, you'll change the element. You'll go to a different spot in the periodic table to look. The other terms we talked about were atomic mass and mass number. For the atomic mass, we said that is the average mass of all the isotopes we can find in nature. And that's why you end up seeing this decimal place out here. While most of the helium in the universe has 2 neutrons, and that's why it has an atomic mass of 4, there are some other types of helium out there, and so we have that decimal place out there to show us there is some small amounts of other types of isotopes for helium. The mass number is, of course, the number of particles that's in the nucleus of an atom. That is the addition of the protons plus the neutrons. I hope you guys found this helpful, and we will see you guys on Monday. Okay, take care.